So we agreed we are working on 2019 November. So we start off and we agreed we are working on 2019 November paper. So I want us to go through it and then we see how we would have performed in case we are the one doing the exam. So I'll be projecting the paper. Maybe we'll, it's important you have your papers, especially the notes. And I believe we'll be able to go through it. So good morning, everybody.
Good morning.
Morning to sir.
Okay. Then I know we are now together. So this is the photo. I don't know whether I can be able to zoom it a bit. Is it visible from your end? Is it visible?
Yes.
Okay. So outline 4 conditions that are necessary for a deadlock. I think that one is a straightforward question. When you're told to outline, you don't explain. It's like you're being asked to list 4 conditions necessary for a deadlock. So the first one would be what? We can utilize the chat section for those people who are able to use the chat section. I think the first condition we said was circular weight condition. We talked about hold and weight. We also mentioned something to do with mutual exclusion. What was the 4th condition? Yes? Very fast, we are revising. We have them in our notes. There was also non-preemption. Are we reading from the same script?
Yes.
Okay, now explain 2 objectives of operating system. Yes? You can raise your hand and answer the question.
Take us through.
We go through together.
Because most of these things we have them in our notes. So if I'll be the one talking throughout, then it will be too much for me. Yeah. Or I do say pass. Where the items are in our notes, I just say pass. Or maybe refer to a particular page in a particular topic so that we move fast. So if you look at part 2 of A, what are the objectives of operating system in computers?
1.
Yes.
That they are efficient.
Yes, there is efficient, meaning that the operating system manages the system resources. Efficiency in terms of managing system resources in an efficient manner. What is the other objective of operating system?
User's convenience.
Yes, there is user convenience. That is very important. The interface between the application and the hardware, making the computer more convenient in terms of usage. Another objective. There is also the aspect of simplicity. There is the aspect of security. There are many answers, but I think we mentioned the number. I think there were 3 in our handout. B, process synchronization is important during execution. Explain 2 methods employed by operating system to achieve it. How do we achieve synchronization? Communication between one process and the other during execution. That's what you're talking about, process synchronization. What methods does the operating system employ in order to enhance process synchronization? Yes? There are many. You're just told to explain 2. Yes? I think there are many. It's only maybe you're not able to relate them, but we talked about message passing. We talked about semaphores. We talked about monitors. We talked about event counters. We talked about critical sections. All these are mechanisms that the operating system uses to enhance process synchronization. So when you look at process synchronization, you're talking about message passing. We are talking about issues to do with event counters, we talked about monitors, we talked about semaphores, we talked about message passing, all those mechanisms employed to enhance inter-process communication will enhance synchronization, coordination on how processes execute. So there are many. So you should not be limiting yourself to any, but there are more than two. So there is message passing, there is semaphore, there are monitors. You can talk about issues to do with critical sections. You can talk about even the aspect of mutual exclusion. It's a process synchronization, so that when one particular process is using a resource, the other one is waiting. What is the difference between fixed and dynamic memory partitioning? Yes, what is the difference between the two? Fixed partition and dynamic partitioning, or static partitioning and dynamic? Yes. Now, anyone who is able to contribute the difference between fixed and dynamic partition?
Yeah, in fixed partition,
Yes.
yeah, the processes are loaded into equal partitions of greater size or equal size.
Yes.
But in dynamic partition, the processes are loaded into partitions of exact size as the process.
Yes. So basically, when you talk about fixed partition, you're saying here that there is the issue of internal fragmentation. You remember, we're talking about the differences, as you can see in the question paper. Differentiate between. So we're saying here when you're dealing with a fixed partition, there is the problem of internal fragmentation. With dynamic, there is a problem of external fragmentation. When you're dealing with fixed partition, it is very simple. But when you're dealing with dynamic, it is complex, because the system has to keep on deciding and making a decision on how much memory does this process require, and then look for sufficient space to allocate that particular process into the main memory. And then when you're dealing with fixed partition, there is what we call inefficient use of memory, because you're saying if you have divided your processes into modules of 10 and the process requires 2, then you'll be wasting the 8, because you cannot bring in another process into that particular hole. But when you're doing dynamic partition, there is efficient use of main memory, because processes are assigned memory that is almost what they require, and that is a plus for dynamic partitioning. And then in the fixed partition, there is little OS overhead. You don't need to do compaction. You don't need to do what we call the relocation of processes. But in dynamic memory, you have a significant CPU overhead, where you have to keep on relocating processes. You have to keep on compacting main memory, and that is extra duty to the operating system. The next question, describe the process of reading data from an I/O device. What is the process? The process of reading data from an input-output device in a system that uses DMA, dynamic memory allocation. I remember we discussed and we were trying to show the differences between interrupt, the differences between direct memory access, and we talked about the evolution of how the CPU has been made to handle critical processes other than input-output operations. Now, when you're dealing with DMA, we are saying here that when the process wishes to read a block of data from an I/O device, it issues a command to the DMA module. So we are saying here that when the process wishes to read a block of data from an input or output device, it must issue a command to the DMA. And this command will basically be issues to do with the address of the input-output device, stating the location where that, the location of memory to be read and the number of words to be read. So the first process, when you're dealing with DMA, the processor wishes to read a block of data from an I/O device, it will issue a command to the DMA, the processor. And that's, if you can remember, and when you look at our notes, I don't know whether I'm able to project them, but I think you should be having them. We said that the CPU is the one that initiates the process, So once it initiates, once it gives instructions to the DMA to start the process of transferring data, it will come finally at the end, where it is just being informed that that particular operation is complete. So the first thing is when the processor wishes to read a block of data from an IO device, it must issue a command to the DMA to initiate that particular process. And it must indicate where the reading is going to take place and how many blocks of data will be transferred. Number two, the processor then continues with whatever it was doing, because now the DMA will continue with the rest of the other processes. So the processor continues with the other work. Number two or number three, the DMA module transfer the entire block of data. And finally, when the transfer is complete, it must send a signal to the processor to indicate that the process is complete. So we are saying the first step, when the processor wishes to read block of data from an IO device, it must issue a command to the DMA. Once the command is issued, the processor continues with whatever it was handling. The DMA module transfers the data or reads the block of data from an IO device. And once the reading is complete, then the DMA must signal. It must signal the processor to tell it that the process has been completed. Those are the four steps. So the CPU is engaged at the beginning and at the end. The DMA the processor continues with whatever it was doing. Once it gives the DMA the power to do the reading of the block of data. So the processor switches to what it is handling, or the processor continues with other work, and then the DMA transfers the data. And once the DMA finishes transferring the data, it must signal the processor to say that the process is complete. Am I alone or we are together?
We are together.
Yes. Any questions so far? So we are talking about 4 steps. Number 1, when the processor wishes some DMA operations to be carried, then it must give the authority to the DMA to do the transfer of data. And then once it gives the authority to the DMA to do data transfer or to read blocks of data, then it continues with what it is doing. The DMA transfers the data or reads the input-output operation that it intends to do. And finally, it must communicate with the processor to say that I'm now done with the transfer of data. That was question 1. How many marks would you have scored if you are the one doing that exam then? Now, question 2A. Explain 2 typical components of file access information. File access information. You have a file that is in your machine. What information will it have in relation to access to that particular information? Of course, one of them is the owner, the user who is assigned control to the file. Who is the owner? What permission or action is that person authorized to do? Those are the 2 typical components of the file access information. So we're saying here the owner, who is the user who is assigned control of the file, and number 2 is the permission, permitted actions. Yeah, what is the owner authorized to do in that particular file? Different owners have different access levels, or different depending on the rights that you've been given. You have limitations, or you could be having the full control of a file. Yeah, and we talked about the various types of access control. If you can remember, we talked about the system, we talked about the what you call the directory level, and we talked about the file level. So here we are talking about the file access information. At this access level of the file, you have 2 typical components: the owner and what we refer to as the permissions or the permitted actions. What can the user do, or what can the owner do? The permitted actions or the privileges that person is accorded. Now let's look at the next question. Distinguish between internal security and external security. What is the difference between internal security and external security file management? Internal security, we are talking about now basically the reliability of the computer system, yeah, to making sure that there is stability of either the operating system and the files that will support this file management. That's what we refer to as internal security. External security, you're making sure that you're protecting files against unauthorized access. Somebody coming from outside. It's very important to figure out the two. Internal, you're taking care of what is inside your computer, making sure that the operating system in your computer, the programs, yeah, that will help you in the file management are functional. External, you're talking about securing your computer from unauthorized access outside. Either the measures that you will put into practice to make sure that your file managements are protected from unauthorized access. That's what we call external security. Internal, you're basically dealing with measures to ensure there is reliability of your computer system, whether it is the operating system, whether it is the application itself that are inside. External, we are talking about the measures that you will take to make sure that the various resources of the computer system are protected from unauthorized access. That is what we refer to as external security. Yeah. With the aid of a well-labeled diagram, explain the typical layout showing track, sectors, inter-sector gaps, and what we refer to as the intertrack gaps. Yes, we had the diagram that we were discussing the other day. You remember? I don't know whether I can be able to go back to our operating system notes. File management. Was it under file management? All around, yeah. That is a track. That's a track. The concentric circle. If you look at the sector, of course, this is a sector. The way it is a pie of the platter. We have what we refer to as the intersector gap. Intersector gap. For example, if this is a sector, this is the whole of this is a sector. But basically, when you look at what you're referring to as the intersector gap, it's a portion. It's a portion running from in here going inside. A portion of it, straight of it, yeah, is what we refer to as the intersector gap. We talked about the intertrack gap. Of course, between this track and this track, that is what we refer to as intertrack gap. We only mentioned the track. Now the area between this track and the track that is already marked is what we refer to as intertrack gap. So we also have the intersector gap. This sector and this sector, this area here, this is what we refer to as the intersector gap. And I think that one, it was not a problem if you were to draw. You can go back to the other question. Let me go back to the other question was asking what? The operating systems are continuously evolving. Explain 2 ways of coping with this trend. How can we cope with this issue of coping with this trend where the operating system is continuously evolving?
Updating by adding new programs.
Updating the patch, yes. Updating the patch, and I think we mentioned about it. How else can we cope up with these? Now, this will mean basically when you talk about the how to cope up, when you're thinking about the updating, then you must have what? Installing internet so that you can be able to do the upgrade and the updates of your operating system, the patch of your operating system. How else can you be able to cope with these changes?
By buying.
By
By buying new operating system.
Yeah, if you can afford, then you can buy. But we're trying to cope. Yes, you can buy, or you could even go for training. Training is also very important, so that you can cope with the trends. I think that one somebody had asked it sometimes back, and I think I mentioned it. Question 3. Somebody had asked about this question, an audit trail, yeah? And we said it is a mechanism that the operating system uses to ensure that it is able to keep information on who accessed the system, which resources, what time did the person log in. So it's basically keeping information. Yeah. Basically is for the purposes of security reasons. You're able to know what time did that person log in. No, who logged in, what time, which resources did that person use, what information did that person update, what did he modify or did she modify. They're very important records. So it's basically keeping chronological track of all activities of the user. Keeps track for the purposes of enhancing security. So we talked about layered operating system. And you remember we also mentioned about the monolithic operating system. And we said it's an operating system that groups related functions together. And you can be able to draw the different layers. Were they 5 or 6? I think there were 6. You should be able now to differentiate between the layered and the monolithic. Differentiate between shared device and virtual device as used in operating system or as used in device management. What are shared devices and what are virtual devices? We all know what are shared devices, yeah? Devices that can be shared between different users, like a printer. It can be shared. But a virtual device is basically a mimic of a physical hardware by tricking the computer into thinking something exists when it really does not exist. It's like having a virtual server, yeah, where you have one server, but you are running 2 or more operating system in it. Yeah, so they are basically the 2 differences. You could be having a virtual memory. Yeah, you don't have it basically in the real sense. You cannot touch it, but you're mimicking main memory using what? A hard disk. The other question is on C. Monica intends to design an operating system with desirable fetching. Okay, just 1 minute. Now, Monica intends to design an operating system with desirable fetching from available memory. Describe 2 fetch policies that should be considered. She wants to design an operating system with desirable fetching from available memory. Yeah. Describe 2 fetch policies should be considered. Of course, now when you're talking about fetching, we have what you call demand paging, and we have what you call pre-paging, because we are talking about issues to do with desirable fetching policies that Monica could intend to design. So maybe you need to write this. I don't think whether we discussed about this. So maybe you need to write it down somewhere. So you could do what you call demand paging. As the word would say is, when you say demand paging, you're only bringing in what? Pages from memory, from main memory, when a reference is made. Demand paging. You're only bringing pages into memory or into main memory when a reference is made to a location on the page. That means whenever a particular page reference is made, you load that particular page into the main memory. And that is why it is called demand paging. You're only bringing pages into main memory when reference is made to the location on the page. You don't load anything into the main memory when it is not necessary or when it is not needed. So you're only bringing pages into main memory or into memory when reference is made to a location on the page. Number 2 is what we call pre. Pre-paging, yeah. So we are talking about Monica intend to design an operating system with desirable fetching from available memory. Describe 2 fetch policies she could consider. And we said, what is fetch? It's more like to read, yeah? It's more like to access policies. It's more like to access. Read is to fetch. To access is also more like fetching. So we're saying here that there are policies that need to be put in place. Now, what are these policies that need to be put in place? Number one is what we refer to as demand paging. Demand paging. We are saying that you only bring pages into main memory when a reference is made to a location on the page. Number two is what you're calling pre-paging. We are talking about pre-paging. This is where you're bringing more pages. You're bringing more pages than are required or that are needed. Yeah, that's what you're referring to as pre-paging. Bringing in memory pages than more pages than are needed. The other one, when you talk about demand paging, demand paging. So those are the 2 methods that you can use: pre-paging or demand paging. So demand paging, you're only bringing in pages into memory when reference is made, but demand paging, you're bringing in more pages than are needed. Those are the 2 mechanisms that Monica could employ. Okay, we can continue. Running process can be terminated by an operating system depending on the prevailing circumstance. Explain 4 such circumstances that can make a particular process to be terminated. Yes, I think this one is in our notes. Reasons for process termination. You remember? Okay, that is fine. Now we proceed on. Yeah, and I think there are many reasons. It could be no more completion, time overrun. It could be memory unavailable, bound variation errors. I think we had mentioned those things back then. Yes. Now the typical characteristic of the 3rd generation. I think that one is already in our notes. Yeah. Are we together? Typical characteristic of the 3rd generation operating system. Explain 2 basic operation associated with a change of a state. 2 basic operation associated with a change of a state. What are the 2 basic? There are more than 2. There are many. Yeah. When a new process spawn of a new process. Yes. Spawn of a new process. This word, the spawn of a process or the creation of a new process, or when a new process is spawned, it will result to what you're referring change of a process state. It could also be the issue of either it is blocked or unblocked, or it has finished. Yes, those are the basic operations associated with the change of a process state. So it is important to note why a process can change state. Either new. So we're saying here that the spawning of a new process can be as a result of those 4 things. Either the process has finished execution, or when a process is admitted, or when a process rolls back, or it is dispatched, or when a new process is created, or a spawn of a new process, or blocked or unblocked. All those are reasons that can make a process to change its state. Now we can continue. Differentiate between reserved and committed pages as used in virtual memory. I think this one we handled last time. Yes, reserved and committed. You remember? I think I mentioned about this. So we said here that reserved pages, yeah, if I can remember how I explained it, was reserved pages, they are a set of contiguous pages, or a set of consecutive pages or contiguous pages within the virtual memory that are set aside for a process, but do not count against the process memory quota until it is used. So they are basically reserved for a particular process, but they will only be used when that particular process need it. Committed pages, these are pages for which the virtual memory manager has set aside space in its paging. So they're basically allocated pages. Committed pages are allocated pages. Reserved pages, they are a set of contiguous pages within the virtual memory that are set aside for a particular process. They are reserved. Yeah, and that's the difference between the two. Committed and reserved. Committed pages, they are allocated pages. Reserved pages, a set of contiguous pages within virtual memory that are set aside for a particular process. That is the difference. Now, there is a diagram here where you're told to, a hard disk has a total of 200 tracks. Now we can continue. We're supposed to go to the next question on the a hard disk has a total of 200 tracks. The process make requests for data from the following tracks respectively. For each of the disk scheduling algorithm, determine the average waiting time. We have not done this. I think we are supposed to handle this should be in the next class. We should be talking about the disk and disk operations. We'll be able to handle this. I don't know how we'll do that in a virtual environment, but we'll try to do our best. Now, when you talk about FIFO, we are saying fast in, fast out. I don't know whether I have a table here, whether we could be able to see it. Let me just see whether it's going to be visible. Sorry, it's too big. Is it visible now? Is it okay now?
Yes.
Now we are saying that they are what we refer to as the disk arm scheduling algorithm. How does the read-write head make decision? So we are saying here that, for example, we have a number of requests that are in the queue. I'm just giving this example here that is, you're given the following information is to be accessed. Track number 95, track 180, 134, 119, 11, 23, 62, 64. Now with the read-write head, you'll always be given the initial position. Is maybe at track 50. And the tail track is the last track. This particular disk is 199. So you are beginning from 0, you go up to 199. Like maybe this is the way it should be. For example, these are the tracks. You have 0, and the farthest point is 199 tracks. So this could be the track number 1, track number 2, 11. You go up to 34. So we are assuming that the system wants to access information track number 11, track number 34, track number 50, track number 62, track number 64, track 95, and so on and so on, as per this information. Now you're asked to perform an operation in order of request, either using the, either it can be fast come, fast serve basis, or it could be shortest seek time fast, or it could be elevator scan, or it could be C scan, or it could be clock, or it could be N scan, F scan, N step, and so on and so on. But now our question is very specific. You are told using fast come, fast served. If you look at the question, talking about fast come, fast served, and they are asking you to calculate the average waiting time. Yes, you're told to calculate the average waiting time. So the first thing that you should do in this case is to draw the diagram like this. You see this diagram the way it is. For the fast come, fast served basis, or fast come, fast served, you will draw the tracks the way they are from 95 up to 64. But the initial point of your read-write head is 50. That is where the read-write head is. So you will go to 95, go to 180, go to 34, go to 123, or 119, go to 11, go to 123, go to 62, then go to 64. That is the way it's supposed to be. But now there is the issue of calculating the average waiting time. And I believe we shall be doing it. I don't know whether we have examples in this handout, but we should be able to do the average waiting time. Let me go back to FIFO. So the average waiting time that you will be calculating, moving from 50 to 62, how many tracks you have traversed? You note the difference. For example, moving from 50 to 62, those are 12 tracks. You note the number of tracks traversed. Maybe it will be 12. You note again, moving from 62 to 64, how many tracks? There will be 2. Moving from 64 to 34, so how many tracks? 30. And then moving from 34 to 11, how many tracks? You calculate the difference and note it. Moving from 11 to 95, how many tracks? Note the difference. Until you now come to the last track, that is 100 and, was it 180? This one. Up to where you have the last track. It could be 64. Or it could be, depending on how the organization is. So you do your calculation like that. For the first come, first served basis is very simple, because you will pick it the way it is here. But if it is shortest seek time first, you're looking at the minimum read-write head movement, and you start with that operation. From 50, you start with that operation. So I want us to look at the way that question I was asking. How would you have handled this question? How would you have handled question 4 at B? You're told to calculate, determine the average seek length, assuming that the starting track is 100. Of course, you'll be given the starting point. So, like for FIFO, for FIFO, you're supposed to look at the question paper, draw the line. Yeah, you draw the line, and then now you can be able to show how the movement of the read-write head will look like. Just 1 minute. Let me change now to the question that is at hand. Now we'll be doing this, God willing, in the next class. Hoping we'll be able to finish up with this. So we are looking at a photo here. I'm going to share this photo. Now, when you look at the question paper, we are asked, we are moving from 55 to 58. You look at what I'm sharing: 55, 58, 39, 18, 90, and 160. Are we together? Now, when the beginning point of your read-write head will be at 100, as you have been told, will be at 100. So what will happen is that moving from 100, moving the number of tracks traversed, I'm looking at the number of tracks traversed. Moving from 100 to 55, how many tracks will you have traversed? 40? 45. You record the number of tracks traversed. And then now you're now at 55. Moving to 58, how many tracks? 3. From 58 to 39, how many tracks? 19. From 39 to 18, how many tracks? 21. From 18 to 90, how many tracks? 72. And then from 160 to 70, how many tracks? 70. Now you're calculating the average seek length. So these are how many? 1, 2, 3, 4, 5, 6. You calculate the total, you divide by 6. You get the average seek length. Are we together?
Excuse me, Mwalimu.
Yes.
Are we getting the number of tracks transferred at FIFO?
Okay, somebody was in the waiting queue. I don't know whether you disappeared. Now, what normally happens is that with what you're referring to as first come, first served, what I'm sharing, maybe I can stop sharing this for a moment. Then I take you back to the notes that we will be going through. Now, when you look at this, I'm trying to use the example that I've already given here. So we are moving from, this is the queue, 95, 180, 34, 119, 11, 123, 160, 162, and then 64. So what you're supposed to do here is that you're supposed to come here, down here. Let me just see whether I can be able to create some space down here. You're supposed to come here and create a table. You're supposed to come here and create a table. Insert a table with 2 columns like that. assuming those are the number of tracks that we will be traversing. Want to reduce the spacing. Home, come here, make it 1.0. I can reduce this, can reduce that, and reduce that. So you'll be looking at this diagram. For example, you have what you call next track accessed. For example, you come here and say next track accessed, and then here you will talk about what the number of tracks, the number of tracks traversed, the number of tracks traversed. Yeah, I want to see how I can reduce the size of these. Now, the current position, for example, in our case here, the current head position is at 50. Head position is at 50. Current head position is at 50. Next track to be traversed. We're noting here the current head position. Position is at 50. It's at 50. So now you are moving from 50 to 95. For example, if you compare with the diagram here, we are now at track 95 here. That is the first. If you look at the diagram here, we are moving from 95, yeah? Now from 95, you'll come here and say 95, for example. But you have moved from 50 to 95. How many tracks? How many? 50 to 95. That is 40?
40.
It's 40. Yes, that is 40. 45. Yes? 95 minus 50. It is how many?
45.
45. And then you come here, go to, if you move to track number, from 95, you move to 180 here. We are moving to 180. So you'll come here and write 180. So from 95 to 180, how many tracks will you have traversed? Because we are moving, yes? 85, yeah? 85, yes. And then now from there, we go from 180 to 34, yeah? This 34. So you come here and write 34 because this is first in, first out. Now from 180 to 34, how many tracks?
146.
146. You write 146. And then you come back. You're looking at 119, yeah? You come here, do 119. Then from 34 to 191, you do 119 minus 34. It's how many? 119 minus 34. It's 85, yeah?
85.
85. And then you come back again. We're at 119. We go to 11. 11. So 119 minus 11. Those are how many tracks?
108.
108. Then we come back. We are moving to 123. 123. Now from 123 to 11. That's how many? 112. And then we come to 62. We come here and do 62. And then now you calculate the difference. 112 minus 62. That is 61. Then you come to the next. We move to 64. From 62 to 64. How many tracks? Put together. Now, in the question, you are supposed to calculate what? For example, you are supposed to determine the average seek length. Average seek length. For example, in our case here, we are doing the average. Oh, sorry. Okay, here. So we are doing here. We are doing the average. We're calling it the average seek length. Yes. So you will do the average. For example, you will come here and do the average. You'll do the average, yeah. And it will be, how many tracks are these? 1, 2, 3, 4, 5, 6, 7. 8 tracks have been traversed. So you will do the total. For example, I can go to the layout and do the summation, sum above. I'll say, okay, so it is 644 divided by, it's 7, divided by 8, yeah? So for example, you will come here and say 644 divided by 8, yeah? Just doing that so that I'm able to put the equal sign is equals to that. So that will be what? Divided by 8. So this will be equal to
80.5.
yes, 80.5. So for example, if you were to do the average seek time for this, it will be now what? It will be for fast in, fast out. For example, number of trucks traversed. I could add another row at the top. Let me just add another row insert above. So this, and then I merge this. So this is for FIFO. Are we together? That is for FIFO. I'm merging that and placing it at the center, and I'll save that because it's also very important. That is for FIFO. Are we together? I'm supposed to come and do and insert rows on my right. I can do again another insert. I can come here and insert row on the right again. And then I can minimize this. And then call this what? Insert. Not really. Now I'm supposed to do that elsewhere. For the shortest seek time, I can do it in another place. But because I don't want to take a lot of time, I can do the same here and call this what? I can merge this. Sorry. I can merge this and call it what? Shortest seek time. Is it next? Shortest seek time fast, or shortest seek time fast. And fast, yeah. Shortest seek time next. SSTF. Now, if I was to do again for the shortest seek time fast, of course, I'll copy this and paste them there as in the diagram. But now what I would do with the shortest seek time fast, you are calculating the closest distance. For example, if this was the diagram from 50, like for example here, our current head position is at track 50. Are we together? That track 50. So now you'll be looking with this Q, which is the closest track from 50? Yes?
34.
From 50. Now, if you do 50 minus 34, is how many tracks?
16.
16, yeah? What about 50 minus 62?
12.
You do the calculation. Which is closer to 50?
62.
62.
So basically now, I'll come here and do what? Closest one. I'll do 62. 62. Are we together? How many tracks will I have traversed?
12.
12. Are we together? So I'll move now. Of course, my current head position is at 50. So 50 minus 62 is 12. Now, when you are in 62, you will come back and check again. From 62, which is the shortest distance that I can go to? Is it 64 or is it 34?
64.
It will be 60?
64.
64. You will come here and do 64. Then what is 64 minus 62 is?
2.
Because we are saying with the shortest seek time, the algorithm select the request with minimal seek time based on the current head position. Now at 64, which is our current head position, which is the closest between 64 and 34 and 64 and 95, which is closer? You can do the calculation. 64 minus either 94 is what? 30. 64 minus 34.
31. So it should be 34.
You go to 34, yeah? Yeah, so you go and say it is 30, 34, and what is the difference? 30, yeah? Is it not the case? If I do a mistake, let me hear from your end. Is it okay?
Yeah, it is okay.
Yes, sir.
Okay. Now from 34, which is the closest place that the read-write head can move? Of course, we have traversed this. I can mark them with red. We've traversed that. We have traversed 34, yeah? And now at 34, which is the closest distance? Is it 95 or is it 11?
11.
11. So we go back to 11. Now 11 minus 34 is 20.
23.
Now we go to 11 here now. We are at 11. We are at 11. Sorry, I should have done red. I should have done red. Now we are at 11. Which is the closest distance? Is it 95? It's 95, yeah?
Yeah.
So I go to 95 here. 95 minus 11 is?
84.
84.
84. 84. Now, from 95, which is the closest distance? This one.
123. 119, sorry.
119, yes. So we go to 119. 119. Now, 119 minus 95 is 20. 24.
Yeah.
Yes. Then we go to 123, yeah? 123 minus 119 is 4.
4.
Then we go to 180, yeah? What is the difference? 180 minus 57, yes, 57. And then now we do our average seek length. So I can copy that and paste it there. And paste. Then we do our total. Sum above. To be 236, yeah? Divided by 8. Will be what?
29.5.
Is equals to 29.5. Now you look at this average seek time. We will also be doing the average waiting time. I believe we shall be handling that, God willing, in another session. You're supposed to do the average waiting time for the same. To do the average waiting time for these particular processes. Yeah, and I believe when you look at this, you will find the note saying how much time, the number of tracks traversed. You can see, like now in the shortest seek time, we are being told the number of tracks traversed are what? What I have highlighted is 236 tracks. Are we together? Am I alone, or are we are together? You can unmute and talk. Now this is the diagram that you're supposed to have drawn. Yes. Now this is the diagram. This is the diagram that you're supposed to have drawn for the shortest seek time. This one, yeah. Move from 50, 62, and then 64, and then 30, and then 11, then 95, and then the same way we have done our calculation here is the same way we are supposed to draw and show this diagram in a graphical way. So the same thing would happen even in the question that is in the exam, the question that is in our handout. You're supposed to draw the same, show that you're moving from the current head position of 100, and then you start traversing based on the shortest seek time or the least number of tracks the head will traverse. And then now you come up with this table. You come up with this table here, like this table. Then now you do what? Average seek length. Are we together? Can we go back to the diagram? We'll also compare with the elevator scan, God willing, and see whether there will be significant difference between the number of the average seek length, these particular different systems. I can save that. I know it will help. It will help us sometimes later. Now I can go back to the question itself, and then we see how it was supposed to be done. Yeah, I'm going to project this. So this is what you're supposed to do, and do the average. Yeah, and do the average for the same. So you can see the number of marks was supposed to be 8 marks because of all this calculation. Are we together? So that's what you're supposed to have done, and I believe we should be able to handle that without trouble. I want to go to the question and share the question paper. Now that's what you're supposed to do for the shortest seek time first, and also for the FIFO. I believe it will be you'll be in a position to do that. Are we together? Are we able to do that?
Yes.
If you have trouble, I'll be sharing the notes on the IO management. You can compare. You can compare with the one that we've done together. So we can go to the next question. Distinguish between the kernel and shell. I think we did that, yeah? The other question is on B, what we were just doing the other day, RAID, a common in financial system. You remember this? Outline 4 advantages of using redundant array of independent disk. What are the benefits of implementing RAID in any organization? Yes? Of course, one is speed, yeah? Sorry? Yes, come again.
What of integrity?
Yes, it's a bit of it, but you know, when you talk about integrity, is a different word from security, maybe, or safety of your
Yeah,
data.
I was talking about security, safety.
Yes, security, yes. Because when you talk about integrity, will be slightly different, but when you talk about security, is very paramount because you're duplicating your data in different location. Another advantage, it is outlining. It's not that, it's outlining, not explaining, yes? Another advantage, the speed of reading and writing is much faster. Of course, there will be large storage available because you're dealing with a number of disks and you're going to do striping. What is going to happen? It will be better because information is in you have large storage available for you, especially when you're doing striping. You have 3 or 4 disks or maybe 2 disks minimum for striping. Again, resiliency of your system. Even if there is a failure, then you're able to overcome it without problem. And then it lowers the cost in terms of, in case of failure, you don't have to spend a lot to get back to the feed. The next question was asking 4 measures that could be used to ensure file security in a computer. 4 measures that you could use to make sure that the data in your mobile phone is secure. Yes, there are many. You can have firewall, you can have password, you can have, it could also be physical security. They are not specific. 4 measures that can be used to ensure file security in a computer. It could be physical, you could even use biometric or face recognition. You could also install antiviruses. You could do data encryption. There are many ways of ensuring safety for your data in the computer.
Hello.
Yes.
Hello, sir.
Yes.
What if you create backups of your files?
What if you
create backups?
You know, backups are okay. Backups. Now we're talking about security. A computer backup may not really help you, especially for security of in a computer.
Okay.
Yes, because we're talking about measures that you take to ensure. Okay, it can help anyway. It can help in one way, but will your data be safe? It has already been stolen. So what do you do to make sure that your data is not stolen? You have a firewall. You have your antivirus. You can have a watchman at the gate. You can have motion sensors to your building. You can have a biometric so that somebody coming to access that data will have to use the biometric, or you can have your data encrypted so that when somebody tries to access that information, he cannot be able to, and many others. Are we together? The table here, we are told table 1 shows the processes with their corresponding arrival and service time in a particular system. Use it to answer the question that follows. Yeah, let me see whether we can be able to go back to that other question. So this is the question. So you're told to do what? The table below shows processes with their corresponding arrival time in a particular system. Use it to answer the question that follows. Yeah, I'm supposed to go to the next page.
Excuse me, sir.
Yes.
Would you please mind explaining the meaning of the word FIFO?
FIFO.
Yeah.
It's fast in, fast out.
Oh.
Yes, it's what we were handling in the other question 5. Was it question 5 or question 4D? It is similar.
Okay.
Yes, it's similar. But now we are supposed to handle it here. Let me see whether I'm able to share this. Now this is a process. The table below shows the corresponding arrival and service time for a particular system. Use it to answer the question that follows. Assuming that you are using the shortest remaining time next, SRTN stands for shortest remaining time next process scheduling algorithm, determine the average and around time for the system. We've not handled this, but I think we should be able to do that. in times to come. Now, when you look at these processes, if you're going to do what you're calling the average turnaround time, how long does it take? If you're going to bring the same, if you're going to calculate the turnaround time using the shortest remaining time next. Shortest remaining time next. So you have to have the table with the following. I don't know how I'll be able to handle this with whether I can be able to reduce this and draw the table somewhere so that I'm able to explain it well. So you'll allow me to keep you waiting kidogo. I open a Word document and see whether we can be able to draw it. Or I could explain. So what you're supposed to do is that you're supposed to have these processes the way they are, and then followed by service time. Service time in the shortest remaining time next. Let me see whether I'll be able to get my notes somewhere, and then I'll be able to explain it much better. Okay. Now, when you look at our first term notes, where we were handling these, I think these are sometimes we handled this. Yeah. Let me this. Yeah. When you're doing what you call low-level scheduling algorithm, where we were talking about short jobs fast come, fast served, or fast in, fast out, or FIFO, fast in, fast out, or fast come, fast served, round robin, shortest remaining time, best response ratio, and multi-level queue with feedback. We handled all that. We were calculating the average waiting time and the average turnaround time. Now, when you look at for example, these processes where you're using short jobs fast, we'll organize the processes based on the shortest job. For example, you have process A, B, C, D. Then, based on short jobs, you have to organize your processes based on the short jobs. The starting time for the short job will be 0 because it will start immediately. Run for 5 minutes, end at 5. And then process D, which goes for 6 minutes, running time is 6 minutes, will run after 5 minutes. So it's cumulatively it will end up taking 11 minutes to complete because it is 5 plus 6. Again, now you go to process C, which is basically 7. That time will be at 11. After 11, maybe 11 minutes. Somebody is joining at this point. Yes, it's going to run again for 7 minutes. Will exit at the 18th minute, and then process A will start after 18 minutes, run up for 10 minutes, and end up finishing at 28. Now, when you're calculating the average waiting time, you base it on the start time of every process. Process B will start at 0. Process D will start at 5. Process C will start at 11. Process A will start at 18. Now, what is the average waiting time for these processes? Calculate it using now the start time of these processes. Are we together?
Yes.
So what is expected of us here is, in this question, we were supposed to organize those processes. For example, you have process A, B, C, D. You organize them, and you're basing it with what? The question was asking us based on, let me just go back to the question. It was asking about, we were supposed to calculate the shortest, the average turnaround time, yeah? We're supposed to calculate the average turnaround time for the shortest remaining time next. Shortest remaining time next. So you will organize your processes. The service time basically is in seconds. The arrival time is 0. Waiting time, in fact, they have done almost arrival time. You've been given the arrival time. Yeah. So in actual sense, you're supposed to organize your work in such a manner. Yeah, where you have process A, you have process B, you have process C, you have process D. And then you're supposed to calculate the waiting time and the turnaround time. These two, you're supposed to calculate these two. Now, I think we'll be able to continue from there and handle this, God willing, in the next lesson. As I can see, we've gone past time, but you can be attempting at your own time, but we will be able to revisit this, finish this paper, and go to the remaining part of the notes after read. Are we together? So we will finish the paper. We will finish the paper for this 2019, and then continue with where we left after raid. You remember raid? We'll continue from there. We'll continue from the raid, the notes, the remaining part, where we are calculating issues to do with the disk and disk arm scheduling algorithm. But we have already done two today. So we will do the rest and then finish this paper. I'll have organized, see how I'll organize the notes in the question, the answer in a better way, so that we're able to relate together. Are we together?
Yeah.
Yes, I can see a question here from Douglas Nyaberi. Authentication, authorization, and accessibility in protecting a file. What was this question, Douglas?
So I was asking if can you discuss probably in form of file protection, like authentication, authorization, and accessibility?
Now, when you talk about authentication, it's just means of confirming that you are who you say you are. That is authentication. Authorization is basically now giving you permission to access that particular information. And then the other is accessibility in protection of a file. I don't understand the other part, but the difference between authentication is confirming that you're who you are. Authorization is that ability to allow you in based on your credentials. Yeah. What are you authorized to do if you're a student? Yeah. What can you do? That is basically what you call authorization. Authentication is confirming that you are who you claim to be. Authorization is the extent to which you are permitted to do based on your access privileges. That's the difference between the two. Is that okay?
Yes, and accessibility in file protection.
Accessibility in file protection. Let me go back to your chart again. Accessibility in protection of file is the ease of basically this is the ease at which you can be able to either read or write to a particular file. That's basically what you're referring to as accessibility. How long does it take for you to do the reading or the writing?
Thank you.
Now, I was wondering whether I sent the notes. So I wish you well. We meet again on Wednesday. Wednesday morning, yeah?
Yes.
Okay. Sasa, enjoy your weekend. God bless.
You too.
Thank you.
Thank you.
Okay.